Hi dear student, in this video solve example 1.1 from the book Heat and Mass Transfer by Cengel, 5th edition. This example 1.1 is relevant about heating of a copper ball. Let's come toward its statement. A 10 cm diameter copper ball is to be heated from 100 centigrade in average temperature of 150 centigrade in 30 minutes. Taking the average density and specific heat of copper in this temperature range to be, this is the density's value, that is 8,950 kg per meter cube, and the Cp value for copper is 0.395 kJ per kg centigrade respectively. Determine the total amount of heat transfer to the copper ball. How much heat is transferred to the copper ball in order to rise its temperature from 100 centigrade to 150 centigrade, the average rate of heat transfer to the ball, and the average heat flux. Let me write the data that is provided in the statement. First, initially the temperature is T1, that is 100 centigrade, and then after heat is supplied to this ball, its temperature rises up to 150 centigrade. Time that is given is 30 minutes. Convert into second, multiply with 60. So you will get 1800 seconds. The density of the copper is 8,950 kg per meter cube. The Cp value of copper is 0.395 kJ per kg centigrade. What we need to calculate, first one, that is the total amount of heat transfer to the copper ball. How much heat is supplied to this ball to rise its temperature from T1 to T2, that is Q. We need to calculate. And the second one is the average rate of heat transfer to the ball, the rate of heat transfer. And the third one we need to calculate, that is the average heat flux. So let's come toward its solution now. As we know that the heat supplied to this ball is equal to the change in internal energy, and this change in internal energy is equal to mCp, change in temperature. What is change in temperature? That is 150 minus 100, and it is 50 centigrade. The Cp value is also given, and we need to calculate the mass of this copper ball. How you will calculate that? We know that density is equal to mass per unit volume. So you can say that mass is equal to density time volume. Density is given in this statement, and the volume, we can say it is equal to pi by 6 of this copper ball, that is also given, that is 10 centimeter. So you can say that diameter is equal to 10 centimeter. Divide with 100 to convert into meter, and it will be equal to 0.1 meter. And the volumes of this copper ball is pi by 6 d cube, not square. Now simply just puts the value. The density of the copper is given, that is 8,950. D is the dia of this copper ball, that is 0.1. When you solve this on calculators, you will get the mass of the copper 4.686 kg. Now mass is calculated, Cp is given, you can easily calculate, then put in this formula, and you will get the heat that is supplied to this copper bar. This mass, that is 4.686. Cp value, that is 0.395. Change in temperature, that is 50, and you can multiply this with each other, you will get the heat that is supplied to this copper ball, that is 92.6 kilojoule. This is our first requirement that is asked in the statement. The next is to find the heat transfer rate. The heat transfer rate is equal to the heat that is supplied divided by the total time in which time it is supplied, that is 1800 seconds. And you could solve this on calculators, you will get the heat transfer rate, that is 0.0514 kilojoule per second. This joule per second is also equal to watt. We can also say that 0.0514 kilowatt. And then the third one is to find the heat flux. Heat flux is equal to the heat transfer rate per unit area. So heat transfer rate is 0.0514 divided by cross-sectional area, that is pi d square. Is d, the value of diameter is 0.1. Take 0.1 square. When you solve this on calculator, you will get the heat flux Q value, and it is 1636 watt per meter square. And this is our final answer of this statement. I hope you understand. If still there in confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet. Thank you so much.